Welcome to Unit 3, Systems of Equations. Don't forget, you can find all of my YouTube videos at LynMona99. So in this lesson, we'll be solving systems of equations by graphing. When we talk about a system of equations, we are talking about two linear equations representing one system. The solution is going to be the point or points where the two equations overlap or that they have in common. Okay, so in this situation, sometimes we'll have no solution when the lines are parallel and there's no common solutions. And then we also have infinitely many solutions when the lines are identical and all points on that line are a common solution. Remember, any ordered pair of a line is a solution to that line. So if you think about this, we're looking for a solution that is on both lines. So we can see these solutions very easily by graphing. So when we're looking at these graphs, the graphs show us that common solution or the solution to the system. If we look at our first, these two lines have different slopes, and we can see that that point right there is where those two lines intersect. So the lines intersect, so there is one solution. If you look at the second graph, we've got two parallel lines. Those lines are never going to intersect. Remember, their slopes are the same, but their y-intercepts are different, right? So those lines are never going to intersect. So these lines don't intersect. So there are no solutions that they have in common, okay? And then our final example is we have two lines here. They are the same line. So they have the same slope. They have the same y-intercept. So these lines are identical. They are the same line. So they have the same slope, the same y-intercept. So all of their solutions, every point on that line is a solution to the system. We call that infinitely many solutions. So here we have an example, and this is a real-world example. So suppose you plan to start taking an aerobics class. Non-members pay $4 a class, while members pay $10 a month, in addition to $2 per class. So we want to write a system that models this members, non-members relationship here. Okay. So anytime we are writing a system, you want to define your unknowns first. So we're going to let X equal the classes, the number of classes we take, okay? And then we are going to let Y equal the total money for that month, okay? So if you think about the non-member, I'm going to change my color here, the non-member equation, so the cost is going to be 4 times every class. The membership is going to be $2 per class plus that 10. So now we can graph those two equations and find the solution they have in common. So here's our two equations. And if we recall, we have y equals 4x. So y equals 4x, so that is going to be a line. Remember, our slope is 4 and our y-intercept is 0. And then our second line is 10 plus 2x. Okay, so those are our two equations. And notice this point right here they have in common. That point is 520. Okay, you can plug that 5 and 20 back into either equation. You'll see it's found in both. And think about, what does that mean? That means if we are planning to go to 5 classes, the cost is going to be $20 on either plan, right? So either plan, it's going to cost me $20 for 5 classes. And then this is where you kind of interpret, so if you're planning on going more than 5 times, you'd pay for the membership, right? Because the cost is definitely less. See how the cost is less for paying for the membership. And if you aren't going to go 5 times, then you don't want to pay for that membership and you just pay by the class. So this is kind of looking at both situations and deciding what situation is going to best fit your needs. But that 5 is kind of our, like, it doesn't really matter. Buy the membership, don't buy the membership, it's up to you. So here we're going to graph this system of equations, and notice they kind of give you a hint with the title. There's going to be no solution. Look at our equations here. Notice both of these equations have a slope of 3. So if we start to graph these, we'll graph the first one. Our y-intercept is 2, positive 2, and our slope is 3. So there's our y-intercept is 2, 1, 2, 3, 1. Okay, so our slope is something that looks like this. And then our second line is -2, and our slope is the same, despite my poor drawings. These 2 lines are parallel, so they are never going to intersect, so we have no solution here. And now, with our fourth example, we have a system of equations, and they are going to be the exact same equation. So remember, this is standard form, okay? And the easiest way to graph in standard form is to use your x and y intercept. And our x-intercept is going to be 4, okay? And our y-intercept is 3. And then we can draw that line right there. With our second equation, we have it in slope-intercept form. So again, we find our y-intercept, which is 3, and then our slope is -3, 4. So we're going to go down 1, 2, 3, and over 1, 2, 3, 4. So our line is the same line. So any point on that line is going to be a solution to this system because it's a solution to either of those lines. Just a quick reminder, don't forget to complete your post-video checks and ask questions. When you don't understand something.